Hi everybody. In the previous lesson, we have covered the definition of data structure and their importance for the software developers. And in this video, we will explore the types of data structures. But before we start today's topic, let's begin with a quick recap of the previous lesson. As I explained in the previous lesson, that how the data structure are used to store and organize information. Not only used for data organization, they also serve different purposes, including data processing, retrieval, and storage. So, with the help of data structures and their types, it's easy to access and update. Now let's take a look on the types and categories of data structures. Data structures can be classified into two categories, which are primitive data structures and non-primitive data structures. First, let's take a look to primitive data structures. Primitive data structures are the most basic and fundamental data structures that are built into the programming language itself, and primitive data structures are available to programmers, so they can use them as a built-in type. The most common primitive data structures include integers, floatants, characters, strings, and booleans. These data structures are found in almost all programming languages. I have included the file in the resources section. Another type of data structures is non-primitive data structure. Non-primitive data structures are more advanced and complex data structures that are built using primitive data structures. They offer us for more advanced functionalities and also allow us to use the efficient way for storing and manipulating the large data. With the help of these data structures, we can handle the complex problems. Non-primitive data structures can be subdivided as a linear data structures or non-linear data structures. So, here is the question: what is a linear data structure? In the linear data structures, the data items are arranged in memory in a linear sequential manner, and they can be either static or dynamic. In static linear data structures associated memory locations are fixed at compile time. Array is a good example of static linear data structure. But in the dynamic data structures, associated memory locations change, and in these data structures, linked list, stack, and queue are included. In this lesson, I'm not going to explain all these types of data structures with details and examples, because in upcoming lessons, we will have full explanation on each types of data structures with deep details and examples. However, when it comes to nonlinear data structure, the data item is connected to several other items and they are not organized sequentially. In this type of data structure, it's possible for the data item to be connected with more than one data items, like graph or tree. These are nonlinear data structures. As you may see, we have different types of data structures, and you might be wondering, why do we need so many different types of data structures? The conclusion is that each of these data structures has a special quality which make them effective in a different situation. For example, maps like Google Map or other maps that you have seen, or the friendship in social media, are perfect for the graph data structures, and stack data structures work perfectly when your application has backward and forward buttons like the undo button in applications. And no worries, we will have full explanation on each data structures in upcoming lessons. Now let's quick recap. Data structures can be primitive or non-primitive. Primitive data structures include integers, boolean, characters, and strings. And non-primitive data structures can be linear data structures or non-linear data structures. You can see in graph Linear data structures has static data structures and dynamic data structures. In a static data structures, we have array, but in dynamic data structures, we have queue, stack, and linked list. In nonlinear data structures, we have tree in graph. Now time for homework. Comment below and say which data structure would you use to build a music playlist app. Explain why. So hopefully you have understood different types of data structures that we have. And in the next lesson, we will look to the algorithms. Also, don't forget to like, subscribe, and hit the bell icon. Thank you for watching and happy coding.